Good morning. In my previous classes, we discussed about approximation methods, and we also classified approximation methods into different categories. Perturbation theory is such approximation method. Perturbation theory can be have two different versions depending on the time dependence of perturbation. First one is time independent perturbation theory, in which perturbation is independent of time. Time dependent perturbation can change splitting of the energy levels, which is the case for non-degenerate perturbation. It can also lift the degeneracy of the energy levels and causes splitting between them, and this case is observed for degenerate perturbation theory. And another perturbation theory is time dependent perturbation theory. Time dependent perturbation theory cause transition between different levels. The appearance of optical spectra is due to time dependent effect of perturbation. Say we take a Hamiltonian, say H, the exact solution of H is unknown. So to solve H, we use perturbation theory. So as you know that in perturbation theory is a approximation method to get a solution for a problem starting from the exact solution to a related similar problem. So we separate H into two parts, and this separation is very much important. We separate H in two parts on the basis of two assumptions. One part is unperturbed part, whose solution is exactly solvable, and another part is perturbed part, which quantifies the deviation from the exactly solvable part. So I can write H equal to H0 plus H prime, where H0 is exactly solvable part and H prime is unperturbed part, perturbation part, or unperturbed part. And H prime is perturbation. And second assumption is this perturbation is much smaller than H0. That is H0 H prime by H0 is very less than 1. So H prime is perturbation which quantifies the deviation from the exactly solvable part. And the solutions of H, that is the, say for example, energy and wave functions can be expressed as a correction to the exactly solvable part. Okay. So first we give our attention or we formulate the theory for the non-degenerate perturbation or due to time independent perturbation. So non-degenerate perturbation So as for any mathematical treatment or mathematical theory, we have few assumptions for this non-degenerate perturbation theories. The unknown total Hamiltonian H can be separated into two parts, H0 plus lambda H prime. Here lambda is called strength of perturbation. If lambda equal to 0, then unperturbed part perturbation is then H equal to H0, and if lambda equal to 1, then H prime. And condition 2 is H prime perturbation is very less than unperturbed part, that is H prime by H0 is very less than 1. Approximation 3, wave functions and values of unperturbed Hamiltonian H0 is exactly known. That is I use here 0, the notation 0, to denote unperturbed wave function and energy. Here psi n0 is orthonormal, that is psi n0 wave function psi n0 are orthonormal wave function. Del nm. Okay, these are three conditions. The next conditions H psi n equal to when perturbation is small, when perturbation is weak, the psi n and En do not differ appreciably from unperturbed solution. That is psi n equal to and En equal to here psi n gives the corrections to psi n0 to get perturbed wave function. Similarly, here del En is corrections to E unperturbed energy due to perturbation. Approximation 5. Psi n, del psi n can be expressed in terms of unperturbed wave function, that is del psi n equal to so we express corrections to wave functions as a series, as a linear sum of the unperturbed wave functions. Note that the contribution from the psi n0 has no contribution to del psi n. So note that there is no contribution of psi n 0 to del psi n. So this is the condition. So this is the approximation 5. So approximation 6. When lambda tends to 0, psi n tends to psi n 0 and En tends to En 0, and therefore we can express del psi n therefore we can write del psi n as yes. Here S is the order of perturbation, order of corrections. So S, if S equal to 1, this is the first order corrections. If S equal to 2, then this is the second order corrections. And since lambda is very less than 1, so these two are converging series. And we can truncate this series depending on our choice or satisfactions of the approximation theory. So our last assumptions is psi n 0 and its corrections term are orthogonal. So based on these 8 assumptions, we develop the theory of non-degenerate time independent perturbation. So using assumptions 5, I write so our aim is to determine the corrections term. So our aim is So our aim is to determine the corrections terms, and so I write H0 plus lambda H prime operating on psi n, and n psi n and I expand these two sides, so I write H0 psi n0 plus lambda H prime zero plus H0 del psi n plus lambda H prime. So I write it here also. This equal to n0 psi n0 plus n0 since H0 psi n0 is equal to en0, so I can cancel out these two from the left and right side, so I can cancel this part. So I can write this as lambda H prime plus 0 this one equal to this 3 del En plus so note that this is psi n and so I multiply by psi n0 from left hand side, then I got lambda h prime psi n plus equal to zero now since del psi n is k not equal to 1, so psi n0 del psi n equal to 0, so I can take this part as 0. Similarly, I take this part as 0 and this gives and this part gives En0 so this part also gives 0 and this gives 1, this gives 1, so I finally left with del En is equal to psi n0 lambda h prime equal to psi n, which I can write. I take lambda outside, so this is so I finally we get this expression, this simple expressions, which gives the energy shift or corrections to the unperturbed energy. So this gives energy shift or corrections to the nth energy level. So to know the nth so to know the corrections to nth energy level, we have to know the wave functions, but so here we know only unperturbed energy, unperturbed wave functions. But do not know psi n. So we do not know psi n. So our aim is to calculate psi n. So to calculate del psi n, which is the shift to the nth energy level, we use another expressions of psi n. So from assumptions seven, we know del psi n is lambda s on to infinity, and so since psi n is equal to so I use these expressions plus s equal to 1, so lambda psi n 1 plus lambda square psi n 2 plus lambda cube in 3. So psi n1 gives the first order corrections to psi n0, psi n2 gives the second order correction to psi n0, and so on. And then del En, so I can use this one, del En is lambda psi n0 h prime, and then this expression psi n0 plus lambda psi n1 plus lambda square psi n2, and so on. So it can be simplified as lambda h prime psi n0 plus lambda square psi n0 h prime plus lambda cube psi n0 h prime and so on. So I write so I can write this part. So del En, I can write del E1 plus del E2 where del E1 is first part lambda psi n0 h prime 0, del E2 is lambda psi n0 h prime psi 1 del E3 this would be lambda square, so lambda cube h prime and similarly I write in general expressions S is lambda to the power S so this gives the first order corrections to energy, first order correction to nth energy level. This gives the second order correction. This gives the third order correction. And this gives the eighth order correction. So this is the eighth order correction to nth energy level. Energy level. So you note that if we know psi n 0, then we can determine first order correction. If we know psi n 1, then we can determine second order corrections. If we know psi n 2, that is the second order correction to nth wave functions, then we can determine the third order energy corrections. And in the same way, if we to know the nth order corrections, to know the nth order correction to energy, we have to know s minus 1 correction to nth level. So we can write to know the nth order correction to energy, nth energy level, to special corrections to the nth energy level, we have to know s minus 1th order corrections to nth wave function, nth wave function, that is psi n s minus 1. So we have to this. Okay, so we can write these expressions as, if we can write this one del E okay, and then I can write this one lambda to the power s psi n 0 h prime. This is the general expression of energy level, energy corrections. So this is the very important equation. This is the very important equation. Okay, so we can, and in that case, so we have to calculate the s minus 1. So we have to calculate psi n s minus 1, psi n minus 1, where s equal to 1 to we have to calculate to know del psi n n. So finally En is equal to En0 plus del En. Del En gives the corrections to zeroth order energy, unperturbed energy, to get the nth energy level of the unknown Hamiltonian. So I can write En0 plus this one lambda is the strength of the perturbation, you know. So this is the nth order correction. So okay, so in my next class I calculate psi n s, that is the nth order corrections to the nth wave function. Okay, thank you.